Okay, so more on homework 6, more on the scientific notation. What we're looking at is 2 times 10 squared multiplied by 3 times 10 to the 4th. So recognize 2 is being multiplied by 10 to the 2, and then this piece is being multiplied by 3 times 10 to the 4th. So we have multiplication straight off the board, or straight across the board rather. So all of these pieces are being multiplied. So I could really write this as 2 times 3 times 10 squared times 10 to the 4th. Well, and recognize this is coming from, I can rearrange this multiplication to look like this. Well, that's simply because something like 2 times 3 is equal to 3 times 2. So that's saying the order of multiplication does not matter. So we can rearrange this multiplication to look like this. We do that because, well, we know what 2 times 3 is. That's 6. And we're going to multiply by 10 squared times 10 to the 4th. So we're making headway. Now, the big question is, what do I do with these 2 powers of 10? Well, recall squaring or raising to an exponent is saying multiply 10 by itself 2 times. This is saying multiply 10 by itself 4 times. So really what we're looking at is 10 times 10 from this piece times 10 times 10 times 10 times 10. We have 2 copies of 10 from the 10 squared, 1, 2, and then we have 4 more copies, 1, 2, 3, 4, from the 10 to the 4th piece. Well, recognize that's 6 times, how many copies of 10 do you have? 1, 2, 3, 4, 5, 6. So that's a long way of showing when you have the same base, 10 in this case, being raised to different powers, and those bases are being multiplied, we can add those powers. So here the base is 10 for each of these. We have 10 to the 2 times 10 to the 4. Because we're multiplying, we'll add the 2 and the 4 to get 10 to the 6, which is a consequence of this intermediate line. So it looks like our solution is 6 times 10 to the 6. 6 times 10 to the 6. A quicker, more shortcut method would be, well, 2 times 3 gives you 6. 2 plus 4 gives you 6. So once you see it work through in this route, recognize we can short circuit this whole process by taking 2 times 3 to give us the 6. 10 squared times 10 to the 4th gives you 10 to the 6th. So add the exponents on 10, multiply the factors out front. All right. Let's see if we have any more. I'll let you try that one out. More of the same, and I believe, okay. Rewrite the following statement using a number in scientific notation. My new music player has a capacity of 410 gigabytes. Recall that giga means billion. All right. So we have 410 giga. Well, okay, we'll finish it out. Bytes. Giga means billion. So I have 410 billion bytes. B-Y-T-E, yep. Where billion, so recall, 1,000 is 10 to the 3, million is 10 to the 6, billion is 10 to the 9, so I have 410 times 10 to the 9 bytes. Simply replacing billion with what it is, 10 to the 9th. And from here, recall we need to get this multiplicative factor that's sitting out front to fall in between 1 and 10. So I need to move my decimal place 2 spots to get 4.1 times 10. Those 2 spots we moved, the decimal, need to be accounted for with this power of 10. So we'll add 2 more to the 9 to get 11. So that would be 4.1 times 10 to the 11. 4.1 times 10 raised to the 11. And hopefully it's not looking for 4.10. So moment of truth. Oh, we got it. Yay. All right. The diameter of a certain bacterium is about 0.00009 meters. The diameter of a certain bacterium is about blank meters. Okay, so we need to convert this point. How many zeros we got? 1, 2, 3, 4 zeros. We'll just finish it out down here. So we have 0 0.1, 2, 3, 4 zeros followed by a 9. That'd be meters. So I need to move my decimal place 1, 2, 3, 4, 5 spots. So it'd be 9 times 10 to the 5. 1, 2, 3, 4, 5. That'd be meters. Now keep in mind, here's where we run into, should this be plus or minus? Well, 9 times 10 to the 5th is a very big number. Look it over here. This is not a big number. It's a small number. So hence it will get a negative exponent. So 9 times 10 raised to the minus 5. All right. And I think million per unit, per minute. Okay, we'll go over this one too. 2.4 million deaths per year in a country express this quantity as deaths per minute. So this is really linking that unit analysis from homework number 5 to the scientific notation from homework number 6. So we have 2.4 million deaths per 1 year. And we want to get this in deaths per minute. So I don't want years, I want minutes. So years needs to go away, so I need to introduce years upstairs. So years downstairs will go away. The only thing I know about a year is that it has 365 days. So 1 year is 365 days. I don't want deaths per day, I want deaths per minute. And I know, so I don't want days, so I need to introduce a new fraction where days is upstairs, day downstairs, undoes day upstairs. I know there's 24 hours in 1 day. I don't want deaths per hour, I want deaths per minute. So I got one more fraction. Hours downstairs, so I needed an hours upstairs. So hours upstairs undoes hours downstairs. I want deaths per minute, so it would be nice to introduce minutes here, and that's convenient enough because I know 1 hour has 60 minutes. So we'll take 2.4 million, where million is 10 to the 6th. So 2.4 million, 2.4 times 10 to the 6th. Just multiplying straight across is all I'm doing. I converted 2.4 million into 2.4 times 10 to the 6th. Times 1 times 1 times 1. Units that survived upstairs. I have deaths. Everything else went away. Downstairs I have 1 times 365 times 24 times 60. units that survived downstairs. Year went away, day went away, hour went away, minutes survived, which is exactly what I want. I want deaths per minute. To finish this one through, we'll do the multiplication. So upstairs I have 2.4 times 10 to the 6th deaths. You could multiply this out more. I just like it compact in this fashion, so I don't have to keep track of 6 zeros, or it'd be 5 zeros in this case. 365 times 24 times 60 gives me 525, 600 minutes. And to follow this one through, I'll take my 2.4 times 10 to the 6th, and I'll divide that by 525, 600. 4.56621, and that'd be deaths per minute. Do we have to round to one decimal place as needed? So this becomes 4.6 deaths per minute. Moment of truth, 4.6. Hey-oh, nice. We got one. I'll let you try this one. It's very similar to what we just did, and I think that should round us out. And I'll let you also try this one. It follows the similar process, but instead of looking at deaths per year, you're looking at the amount of candy eaten per year. So a couple words on this one. Countries, people consume 7.5 billion pounds of candy. Express this quantity in terms of pounds per person per month. The population of the country is 305 million. Okay. So in fact, let's go through this one together. So we have 7.5 billion pounds of candy, and we want to know pounds per person per month. So we want pounds per person, so let's go ahead and right away take the 7.5 billion pounds and divide it by the 305 million persons. So we have 7.5 billion, 10 to the 9, that'd be pounds. That's pounds of candy per 305 million people. So this is the amount of candy, this is the amount of people. So we'll get the amount of candy eaten by one person. And this is in within a year's time. So this becomes 7.5 times 10 to the 9er divided by 305 times 10 to the 6er. So we get 24.59016,393, and this would be pounds per person. So for every year, on average, each person eats about 25 pounds of candy. So this is pounds per person per year, and we want to get this per month. So this is the amount of pounds per year. To get the amount of pounds per month, well, there's 12 months in a year. So we'll take our result and divide it by 12. Right? This is 24 and change pounds per person. This is over a year's time. So to get it in a month's time, we need to divide by 12. So 2.04918 pounds per person per year, or per month, I'm sorry. We want to round to the nearest tenth. Nearest tenth, 4 is not enough to round up, so this is going to be 2.0 pounds per person per month. Hey-oh, very nice. All right, I'll see you on the next one.